All right, class, welcome to another day of science class. Today what we're going to do, we are going to be talking about the net force challenge activity. And for this activity class, we're talking about how can you tell the forces of an object, how can you tell the forces on an object are balanced or unbalanced. So by the time we finish the activity today, you should have a good understanding of unbalanced and balanced forces. So the first thing I want to do, class, I want to look at my board here, and we're talking about acceleration. Acceleration is speeding up, slowing down, or changing direction. And you should already know that because we had that in our other activity, but I want to make sure you understand that. Acceleration is speeding up, slowing down, or changing direction. So if we have any of these three things happening, that is considered acceleration, okay? Now, constant speed has a net force 0, okay? Net force 0. That means it's not accelerating. Let me give you an example. How many of you guys have a bank account? You got a bank account, James? Anybody got a bank account?
Yeah.
Okay, a bank account. Hey, good. So when you get money, like from your job, okay, you cut grass, right, to make money, right? When you get money, you take that money and you put it into your bank account, right? That's called what? What's that called, class? Is it called
deposit?
It's called deposit, right? It's called deposit. So when you take money out to buy your mother her present, James, like for Christmas, okay, what do you call that?
Withdrawal.
A withdrawal. Okay, good. So you put money into the bank, right? When you gain money from your paycheck from your job or whatever, and you take money out to pay bills, to buy your mother a present. Her birthday's coming up soon, Mother's Day coming up soon, okay, all those good things. Anyway, so the point is, we have a net force, a net balance, right? So sometimes your net balance, it can be negative, okay? It can be positive, right? So it's the same thing that we're going to learn today when we talk about net force. So if you look here, her thing here, net force is a combination of all forces acting on an object. And here, class, I have a net force diagram. Now we're getting to it, class. We're getting to it now, okay? A net force diagram. And you can see here that we have 10 newtons of force going this way, and we have 2 newtons of force going this way. Now, who can tell me, is this going to be balanced or unbalanced? James, what do you think? Is it balanced or unbalanced?
Unbalanced.
It's unbalanced. Okay, good. No, look. We have 3 ways to describe the force diagram. 3 ways to describe it. We can either say it is, James, come over here for a second, please. She wants to be in the picture, okay? So we have 3 ways to describe it. We can say that either, can you see this part, Adrian? Is he in the way? No? We can say it's either balance, constant speed, or net force 0. Or we can say it's unbalanced, accelerated, or net force. In this case, class, James had already said, can you turn around so you can see, James? This in your back. I want to see your back. So what we see here, class, James already said, and he said correctly, this is unbalanced. This is not the same as this, so therefore it's unbalanced, okay? Which means that this particular force diagram is accelerating. We have acceleration here. This force diagram has a net force. And who can tell me, what is my net force? Can you tell me my net force?
8.
8, that's right. 8 what? 8 what?
Newtons.
8 newtons, good. So what I'm going to do, I'm going to redraw this. I'm going to redraw. Oh, wait a minute. Okay, I'll redraw here. Redraw it. Sorry about that. And my balance is going to be 8 newtons. Everybody see that? You see, because I have 2 going this way, 10 going away, so it's going to be my balance, my net, not balance, excuse me. My net force is going to be 8 newtons. And because I have a net force, it's going to be accelerated and unbalanced, right? Now, how could I make this balance? Can somebody tell me, how could I make this balance? What can I do to make this balance?
Add 8 to that side.
Okay, that's right. I'm going to add, I want to say, okay, I got this one. I'm going to add 8 newtons to this side. Oh, that's not a good color right there. Let's do this one. I'm going to add 8 newtons here. If I add 8 newtons here, this now becomes balanced, which means that it has a constant speed, which means that it has net force 0. Okay, everybody get that? So this is what we're going to be learning today. So this is our first day of learning how to understand net force diagrams. But we do have a little activity for you today. And we're going to be using this right here, which is called a force meter. All right, James. So this is very, we got to be very careful with this one. You got to be careful. Okay, anyway. So look, so what we're going to do, it says, imagine a car that is moving at a constant speed in a straight line. A car. What's our little car? Wait a minute. Don't go. Stay there. Imagine a car moving at a constant speed in a straight line. The frictional forces that would slow the car down are balanced by the engine force that moves the car forward. The result is a zero net force on the car. So this car. So let me give you an example. Let's say you and I are taking a road trip, and I put my car on cruise control. There's a little button, and my car goes the same speed, for the duration of the trip. We call that constant speed, net force zero, because it's balanced. Okay, I'm going the same speed the whole time. Okay. Now, according to Newton's second law, the car is not accelerating. It's not speeding up. It's not slowing down, and not changing direction. An object's acceleration only changes when there is an unbalance. Here we go, the unbalance. An unbalance or a non-zero net force acting on it. Okay, so a net force. Okay, now, so let's get to our activity today. Ready? Here we go, Jane. This is our first time in activity, so this may be a little hard for you today, but let's try it. Here we go, Jane. Turn around. Here we go. All right, so what we're gonna do, we're gonna be using a force meter, and you can see that our force meters have numbers on them. See the numbers, everybody? Has numbers on them. Okay, see the N? That's force, right? N is force. You already know that. Okay, so it says place the block on this table and hook both force meters to it as shown below. Okay, each mark on the force meter is 0.1 newtons. It's 0.1 newtons. And it says, while not moving the block, have one group member gently with 1 newton's force on one force meter, while another pulls gently with 1 newton's force on the other force meter. So what kind, let's guess. If James is pulling with 1 newton's force and I'm pulling with 1 newton's force, is it going to be balanced or unbalanced? What do you guys think?
Balance.
It's going to be balanced. Good. So let's do it, James. So James, you're going to make yours say 1 newton, which is right here, okay? I make mine say 1 newton as well, okay? Ready, James? Can you see that? All right. So here we go. So we're going, oh, she can't see it. Are you able to see it? Oh, you can. Good. So let's make it 1 newton, James. So you pour yours 1 newton. You're 1 newton? Wait a minute. I'm a 1 newton. Are you 1 newton? Keep it on 1 newton. See, guys, do you see what's happening here? He's pulling with 1 newton and I'm pulling 1 newton. Okay? Is there any motion going on? No motion. Constant speed. Now let's look at your paper here, okay? So it says, how can you tell? Okay, now it says procedure number 2-3. Draw a force diagram from the video. That's my demonstration here. Demonstrating each person pulling the force meters with 1 newtons of force. So class, you're going to draw a force diagram. A force diagram, remember, it's going to look like this. You have a box with arrows. So you're going to draw a box of arrows, and it's going to represent what James and I just did. So let's show it again. So we got 1 newton of force. He's a 1 newton. And there is no movement there, right? So you're going to draw that right here. So you're going to draw your little box, and you should have arrows on each side, okay? Now, we're going to go to the next thing now, James. Okay, it says pull gently with, this time, James, pull gently with 1.5 newtons on one force meter, while another member pulls with 1.0 newtons on the other force meter. The other two, yeah. Okay, now, so here we go. Ready, James? You're going to pull, can you just come a little closer to me, James? James is going to pull with 1.5, and Miss Penix will pull with 1. Okay, here we go. I'm pulling 1. He's pulling 1.5. You guys see what's happening, class? It should be very evident. Let's try it again. James going to pull with 1.5, and I'm pulling 1. No, you can't hold. Don't hold the block. That's cheating. Okay, ready? You do 1.5. I do 1. Keep it at 1.5, keep mine at 1. You see what's happening, class? Okay, good. This time, you're going to draw a force diagram. So I mean, that was piece number 2. It says now, draw a force diagram of the block from the video, that's the demonstration here, demonstrating one person pulling with 1.5 newtons. That was James pulling with 1.5 newtons. And the other person, Miss Pence, was pulling with 1.4 newtons. So you're going to draw your force diagram. Remember, force diagram is going to have a box and your arrows. So remember, James pulled with 1.5 and Miss Pence pulled with 1 for 1 newton's force. Okay, good. Now we're on the next one. Okay, it says, yes, yeah, Okay, did that already. Now, it says unhook one of the force meters, place 2 metal cylinders. This time, James, can you do that, James? Place 2 metal cylinders. We're going to unhook one of these force meters. Can you put your cylinders like this, James? See how they are? Not like this, James. They're right next to each other. Nope, not like that. One more time. Try one more time. There you go. And you're going to put your rubber band. All right, ready? Okay, so then it says, practice pulling gently on a force meter so that the block slides steadily and slowly as possible. Okay, James, so I want you, let's put right here. Can you let go for a second? Come a little closer. Okay, I want you to pull this steadily, James. Go ahead. And let's see what it says. Try to be steady. Keep going. Do you guys see the, what's the force there? Are you able to see the force? It's 0, isn't it? Keep going. Try to be steady. See that? What is it? It's 0, isn't it? Mm-hmm. Okay, now let's see. It says, when you can do this well, read the force meter, force needed to pull the block slowly and steadily. With the group members, discuss the motion of the block, in particular, identify all the forces on the block, and decide if the block was accelerating or not. Okay, so was this block accelerating or not, James? Do you think it was accelerating? Was it accelerating, or did it have constant speed? Which one did you think it had?
Accelerating.
You think it was accelerating? Okay, let's look at that again. I want you to pull it. Pull it one more time. And look at the force. When it's steady. Okay, look. When it is not steady, what happens when it's not steady?
Constant speed.
Is constant speed, or you change your mind again? Which one is it, constant speed or accelerating?
Right.
So when you pull it steadily, the word steadily means something.
Constant.
Okay, I don't want to give answers. Okay, good. So we saw right here. Look, can you see this again, Jamia? I really want to understand the force here. When I pull it, wait a minute, it's not steady yet. Don't you look at it, but look, it's not steady yet. See how it happens when it's been steady? What the force is on there? See that? Okay, good. Okay, so look here, class. So it says, draw a force diagram of the block from the video, demonstrating pulling 2 metal cylinders steadily and describe the motion of the block. Title your diagram, 0 net force. This is the reason why it says that. 0 net force. Because we know that it was constant speed, right? Okay, good. All right. And now on the back side, we have analysis questions that you're going to be able to answer on your own, okay? So you should be able to do this based on what we did in lab. Make sure you go back to the board here to help you. All right, class. Let me see if I can talk about anything else that I got to talk about. Nope, I think I did everything I want to talk about. Okay, any questions, class? Okay, yeah. So just make sure you go through this class and it'll be good. All right, let's say thank you to our helpers again. So we have James. Say something, James.
Hi.
No, we leave it now.
Bye.
Bye. Okay. And then my daughter, Jamia.
Hi, or goodbye.
And of course, I got to do my little, all right, class. I'll see you in class. Bye-bye.